Hi everyone. I just give you back the exams. And these exams, we have great improvements. Hi. Yes. Hi. Okay. So the high score is also 96, same as last time. Lowest score is 3. And average, average is 66.76, which is nice. So we have 5 A's, same as last time. But we have 8 B, yay! And we have 4 C, 4 D, 1, so these are F, so 8 F, and 4 students didn't take the exam. Okay, so what do you feel? So I know you study hard on the practice exams, right? Did you all read the practice exam review sessions? Make sure you remember all the steps, and then do you think the actual exam is also similar to the practice exam? Yes. Okay, so I hope you continue to do your good work and then also get good scores on exam 3 and the final exam. You can use your final exam to replace the lowest midterm score. Right? Hi! Come here and pick up your exam. Alright. So, the exam scores I also posted on the website so you can see. Okay. Hi, Dre! Come and pick up your exam. Okay. So I also posted the solution. So this is the solution. And this is the exam 2 common mistakes. And then the exam score is right there. Okay. So I will, after exam 3, I will also put the scores here. Then you can compare. All right, let's look at the solution. The first problem. Divide using long divisions. So we put the dividers here, put the divisor here, and then we ask what number times 2x squared to get 10x to the fourth. So we get 5x squared. 5x squared times that is 10x squared. 5x squared times 3 is 15x squared. And then we use the first line, subtract the second line. So some of you add them. No, we want to subtract. So negative 3 minus 15 is negative 18. Okay. And then 4x squared and 5 right here. And then 7x times 2x squared, we get 14x cubed. So 7x times 3 is 21x. We use our first line subtracts the second line. That's why 4x minus 21x is negative 17x. And 5 minus negative become plus. So 5 plus 27 is 32. So this equals to quotient, this is quotient, plus remainder over divisor. So some of you forget the plus. It's very important to have a plus here. Otherwise, you mean 9 times that. No, it's not times, it's plus. So that's part A, long division. Okay. Part B, synthetic division. Synthetic division only works if you have a divisor is in the form of x plus a number or x minus a number. That's why part A, you have to use long division because that is x squared. Okay? So part B, synthetic division. This is x plus 5. So the roots is negative 5, not 5. So this is negative 5. And how do we do it? We move the 2 down here. Use 2 to multiply by negative 5. So we get negative 10. Put it in the next column. And then add those two numbers. We get 1. 1 times negative 5 to get negative 5. Add add them. Continue. And because we don't have x squared, that means 0x squared. So some of you missed that 0. Okay. So that is part B. And this is the remainder, and this is the quotient. Therefore, this equals to the quotient minus 46 over x plus 5. Hi, come in, pick up your exam, Isabel. And yes. Yeah. Hi. Oh. Okay. So, let's also look at the common mistakes. All right. So I just took some pictures of the common mistake. I hope you okay with that. I don't remember who made this mistake. So I hope all of us can. Hi, Hi. Yes. I hope all of us can learn from our mistakes. Okay. So mistakes are our friends. They help us to improve. Okay. So here, use the first line, subtract the second line, okay? And here, use the first line, subtract the second line. All right. And at the end, you put plus. This is plus. Quotient plus remainder over divisor. Yes. And then right here, this is divisor, this is quotient, this is remainder. Okay? And so be careful, this is wrong. Okay? This fraction equals to the quotient plus the remainder over the divisor. Okay, so be careful. And then part B. The error here, so here we want to multiply them and then put it here. So not add, okay? So we don't add them, we multiply them and here. And then these two numbers, we want to add them, not multiply them. So this operation, you gotta be very careful. Make sure you remember right. So we multiply them and put it here. And then these two, we want to add them and put it here. And then here, the common mistake is miss the x squared, so there's a 0 here, so that's the mistake. And see, miss the 0. Okay. And then this is the quotient, so this fraction equals the quotient plus the remainder over the divisor. Divisor is x plus 5, okay. The root is negative 5. All right. And then number 2, condense into a single log attendance sheet here. All right, so yeah, so the log, we can combine the sum into products, the subtraction into division, and we can move the power up there, right? And here, how do we expand it? We can expand it, right? And then if that factor is in the numerator, we add them. If the factor is in the denominator, we subtract them, right? And then the exponents, we can move it in front. Okay. So if you just arrived, come here and pick up your exam. Yeah, come here and pick up your exam if you just arrived. Okay. So let's look at the mistakes. Okay, so here the mistake is combine the addition into products. So this is multiplication. This is multiplication. And here, this when you pull the exponents, don't pull the sign. Okay, so only put the 3 over 7. Don't put the negative. That's why you still have the negative here. You put this factor in the denominator. So this exponent is still positive. And then here, part B, see, this is fifth root. Fifth root means this guy to the 1 over 5. So you also want to put the 1 over 5 down up in front. Okay, and here log splits them, but it's the log of each factor. Okay, not log of the whole thing. So log of this guy minus log of that guy plus log of that guy. Okay. And here, so the division becomes subtraction. So this is minus, this is minus. All right. And then problem 3. Problem 3, we use the rational roots theorem. So we look at factors of the constant term and factors of the leading coefficients. And the positive roots, we use these numbers divided by that number. And then we try, so here we have 4 numbers. We try one by one on the list. And when we plug in 1, we get P of 1 is 0. Yay! We find one root that we can stop. So we know 1 is a root, so x minus 1 is a factor. Okay? Therefore, well, use synthetic division, we can get, this is, so P of x equals x minus 1 times x squared minus 4x plus 13. Right? And then, if you can factor it, that's great. But if you cannot, use quadratic formula. Quadratic formula. 2a negative b plus or minus square root of b squared minus 4ac. Okay? And 4 times 13 is 52. 60 minus 52 is negative 36. Square root of 36 is 6. Square root of minus 1 is I. Therefore, split them. So 4 over 2 is 2. 6 over 2 is 3. So 2 plus or minus 3i. So we have one rational root, and then the other 2 roots are complex conjugates. So I give you in the hint, complex conjugates. Okay, everybody? Use quadratic formula to find complex roots and irrational roots. So the common mistake is students forget to use the quadratic formula. Okay, once you know you're not able to factor it, then use quadratic formula. Okay, everybody? Hi, come here. Come here, pick up this. Oh. Come here. Okay, so problem 4. First, we set the numerator equal to 0 to find x-intercept. X-intercept is points. And then we plug in x equal to 0 to find the y-intercept. And then we set the denominator equal to 0 to find vertical asymptote. And we let x goes to that number from the right and from the left to see whether y goes to infinity or minus infinity. Here, negative number over 0 plus is minus infinity. By the way, minus 12 minus 21 is still minus, right? Be careful, this is not multiplication. So your numerator is negative. That's why you get negative infinity. Okay. And part D, horizontal asymptote. Oh, yes?
If I put a decimal for negative 21 over 20, is it okay? Or is that like wrong?
What do you mean?
Like,
Oh, yes, that's correct. Mm-hmm. Yeah. Oh, yeah. And then, yeah, here when x goes to infinity and x goes to minus infinity, y behaves like 3 over 5. So horizontal asymptote y equals 3 over 5. And then you use this information, you can draw the graph. So this is the x-intercept, this is the y-intercept, this is the vertical asymptote. And when x goes to minus 4 from the right, y goes to minus infinity. Okay, that's down. When x goes to minus 4 from the left, y goes to positive infinity, that's on top, right? And then when x goes to infinity or minus infinity, y approaches the 3/5 right here. And then you realize, oh, when we connect them, the top points make more sense. And then here, connect them, looks like the bottom points make more sense. So you connect the bottom points. Right, everybody? Okay, let's look at B6. So here on the left, so x-intercept 7, 0, no 0, 7. Y-intercept 0, -21/22. Yeah. And then x goes to -4, y goes to, see, negative number over 0 plus is minus infinity. Here, negative number over 0 minus is plus infinity. And the picture's right. And also, please mention and behavior, okay? When you let x goes to infinity and x goes to minus infinity, and your y behaves like that. Okay, so don't miss that. Here, vertical asymptote is not a point. X-intercept, y-intercept are points. Vertical asymptote is a vertical line. Vertical line is a equation. Horizontal line is an equation, not a point. Okay, so be careful. So I really hope that you can have a mistake book to collect all your mistakes. And then before the exam, you can review your mistakes. Okay, and then here, next problem, if you get it right, you forget the interval notation. Interval notation. So, I know when you do your practice exam, and when you use the solution to grade your work, did you grade your work carefully? Did you use interval notation? Mm-hmm. So, I really hope that when you look at the practice exam solution and you compare your answers, make sure you don't miss the steps. Okay, so interval notation, that's one point. And then here, well, be careful. This is wrong notation. You mean 11x plus 5 is greater than 0. So x is greater than -5/11. But you don't mean 11x plus 5 equals to -5/11. Right? Here you mean 3x minus 1 is not equal to 0. So x is not equal to 1/3. But you don't mean 3x minus 1 equals to 1/3. Okay, so when you write something down, be careful. Okay? And here you mean 7x plus 13 is not 0. So x is not equal to -13/7. But you don't mean these are equal. Okay, so be careful the way how you write it, even though you get the right answer. But if you write something wrong, then I need to take up some points. Questions?
How come the line doesn't start from -13/7?
-13/7. Oh, okay. So here, x not equal to that. So you put an open circle here, right? Here, x is greater than, which means on the right-hand side of this point. So therefore, and x not equal to 1/3, you put an open circle. So that's why this is an open circle, but we don't consider that because x must be greater than -5/11, and it cannot be this point. Therefore, your interval notation, -5/11, comma 1/3, parentheses, because we don't want to include that point, union, parentheses, 1/3 to infinity. Okay, everybody? Mm-hmm. So now you're going to take more and more math class. Like, unlike your previous math class, many problems you just give an answer. But here you're going to learn more and more complicated problems. So show your work, write it down step by step, and let the audience understand what you are writing. It's also very important. Okay, everybody? Mm-hmm. So not just the answers, but the process is very important. So your work. Okay. And then problem 6. All right. So this problem, because they have different days, we apply ln on both sides and move the exponent down in front. And then here we can distribute and we move the terms with x on the left hand side and then factor out the x and then divided by this prime factor, we get the x. Okay, so this is the solution. Let's look at the common mistakes. Okay, so here 5 ln 3 plus 2 ln 11. Just leave it like that. We cannot combine them. So because this is ln 3, this is ln 11, they're not the same. So we cannot combine and say 5 plus 2 is 7. Right, everybody? So cannot combine, just leave it like that. So that's the mistake. Here, -2 times ln of 11 is not ln of -22. So a number, okay, so 2, let's see, how this, 2 ln 11. So this is ln of 11. This is not the same as ln of 2 times 11. We cannot move the 2 inside the ln. Okay, everybody? So be careful. Just leave the 2 outside of the ln. Don't move it inside or multiply it. And see, 6 ln of 11 is 6 ln of 11. Don't combine the 6 and 11. One of them is outside ln. The other one is inside the ln. We cannot multiply them. Is that clear, everybody? Be careful. All right. And yeah, similar here. See, the 11. They're not multiplication. It's ln of. Okay, so this is a function, not a multiplication. So we cannot switch the 11 in front and get ln of x. No, we cannot do that. So this is -2 times ln of 11. And this is 6 times ln of 11. We cannot multiply them. Okay, so that's part A. So part B, here we subtract 2 first and then divide it by 7. So this line should be longer. And then here we apply ln on both sides. So ln of 5 and then right hand side ln of 8. So make sure you do the same operations on both sides. So you apply ln on the left. You also apply ln on the right. Okay, everybody? So that's why I hope when you do the practice exam, if you have mistake, write down the mistake and write down the correction next to it. Then you know, oh, that's the mistake. So try to avoid a similar error in the actual exam. Okay, so collect the mistake book. And then, yeah, so here, yeah, ln of 8. Apply ln on both sides. Okay, so that's part B, right? Part C. We have a similar quiz problem, right? When you see subtraction, you combine them, it becomes division. And then, yes, so to get rid of the log 2, both sides raise to the power of 2. 2 to the 4 is 16. And then you distribute and solve for x. At the end, do you see at the end, we get this number, and then you put this number into the log to check whether it's in the domain. Do you see this guy? It's negative. So it's not in the domain. Therefore, no solution. Even though you get an answer for x, but it's not in the domain. So no solution for this problem. Okay, everybody? So, do you remember on your quiz? A lot of you forget to check your work. And then I say to you, check your work. Do you remember that? So please have a mistake board and then you can review your mistakes before the exam. So remind yourself, don't forget to check your answers. Right. Okay. So yeah, combine subtractions become division inside the log, and trigger work. Okay, yeah, so trigger work. Combine the subtraction into division inside the log. Yes. So I really hope that when you do your notes, do your homework, okay, if you have some example you don't understand, ask me. Because can you see a lot of like exam problems? We cover some similar problems in class. Do you see that, everybody? So I really hope that you can understand every problem in the class notes. If you don't, come to ask me. So this is how we learn the math. We learn a lot. I know we have a lot. Okay. But, but all these problems you have seen one similar examples in class. So I hope as long as you can understand those and remember the steps, and then you can solve the similar problems on your own. Okay, so this is division. And here, what the student did is move this term on the right and then raise the power of 2. You can do that. But here, see on your right hand side, you raise to the power of 2. And then when you break them, you actually multiply them. You don't add them. See? Exponent rule. X to the A times x to the B is x to the A plus B. So when you break them, it's actually x to the A times x to the B. So 2 to the 4th times, not plus, times 2 to the log 2 of 3x plus 5. And 2 log 2 cancel. 2 to the 4 is 16. So 16 times, this is multiply, this is not add. Okay, everybody? So, yes. So these are the common mistakes. Okay. So, this problem. Remember, I did review session recording. So 8 of you joined the review sessions. And I don't know how many of you watched the recording. Okay, how many of you watched the review session recording or in the review session? Okay, so in the review sessions, we go over this similar problem in the review session, and I also tell you that in the actual exams, I might ask you ln, I might ask you e to the x. Yes? Okay. So I can show you. What did I do? Okay. Review session is right here. Okay. I can find. Let's see. All right. Yes. Yes. So in the review session, I told you in the exam, I might ask you ln, or I might ask you the e. And then we went over these problems, and at the end, I asked you, try that. Okay, try that. So your actual exam now is e. Then try that. So your parent function is e to the x. Okay. Yeah. So it passed through 0, 1. Okay. And you follow the list. So shift to the left 4 units. And then this minus sign reflects over the x-axis. And then here, vertical stretch by a factor of 2. And then shift up 5 units. So this is your graph. So domain is minus infinity to infinity. Range is minus infinity to 5. Vertical asymptote, no. Horizontal asymptote, y equals to 5. I believe only one of you get this right. Okay? Many of you get your parent function wrong. Okay. See? The review session right here. This parent function function log x is only for log ln. If you have exponential function, the parent function looks like that. Okay, everybody? All right. Do you think the video session is useful? Do you want to have video session for exam 3 and the final? Yes? Promise me you're gonna either attend or read the recording carefully. Promise? Yes. When is exam 3? Okay, let's see. Exam 3 is gonna be on the Monday of that Thanksgiving week. Okay, so we can have review session. Do you like to have review session on the Friday or Thursday or Wednesday? Wednesday or Thursday? Wednesday?
I'm gonna send those.
So Wednesday or Thursday? Wednesday, raise your hand. Thursday, raise your hand. Review session. Wednesday again. Thursday. Okay, more Wednesday. Wednesday, 8 p.m. works for you? Okay. So yeah, I will also make recording. So if you cannot attend, please make sure you watch the recording. So I might help you what type of problem on the actual exam, right? So really carefully. And let's look at the common mistake. Okay, yeah, so the common mistake is like most of you put the picture of the ln of x. But I can see all these translations, a lot of you get them right. So which is really nice. That's why only 2 points off because the parent function is wrong. But these 3 points, because if you start with a wrong picture, you're not able to get these 3 points. Okay, so yeah, most of you lost those 3 points. Okay, problem 8. Oh, okay, so we use this formula. Quarterly. How many quarters in a year? 4. So n equals 4. Right, everybody? So that's why we plug in n equals to 4. So common mistake is, yeah, so here n is 4, okay, not 6. 6 is a year, and then so this is nt, okay, not rt. Here, not 25, 4 quarters. Yeah, quarter is 25 cents, but 25 cents is 1/4 of $1, so that's why quarter is 4. Okay, $1 equals 4 quarters. Okay. And then last one, problem 9. Problem 9. This problem is similar to a practice exam problem. The practice exam has rabbits. Now I changed rabbits to chicken. So you get your P0, P of 5 is 220. So you plug in this formula, 250, this is 100. You solve for R. And then 2 years, that's 24 months. So you plug in T equals 24, and you get 8,130. Okay, everybody? So here the common mistake. Oh, by the way, T equals 0, population is 100. T equals 5, population is 250. And your formula, see, e to the r. You figure out the r, put the r here. T is 24. Okay. And initial population is 100. So 100 is here, 250 is there. So and yeah, so right. Okay. That's all for the exam. Any questions about your exam? So you will make exam corrections and fill out the exam wrapper and post that on the Blackboard. Okay, everybody? So this is Blackboard. If you click My Grades, then you can see a lot of scores. So right now, I put the new homework average, quiz average, and self-assessment. You might see very low percentage here because this homework average, we count like 38 homework assignments and we drop the 6 lowest. Okay? Because we haven't learned all the classes yet. So that's why you haven't finished all the homework. So you might have a low percentage. Okay? But as long as we get closer to the end of the semester, you do more homework, this percentage will be higher. And also the quiz. How many quiz we have so far? We have 5 quizzes so far, right? We still have 3 quizzes, and because we dropped the 2 lowest scores, then you'll see your quiz average will go up. And also self-assessment. Self-assessment includes all the practice exams, all the exam correction and records. So these 5%, I hope all of you can get those because you turn in your work and then you get the perfect scores. Okay, so if you miss your practice exams or exam correction and record, please submit those. I still accept those. I will grade them. And please check your scores. If you don't get 10 points, maybe you forget to estimate your total score. The total score is you look at each problem, how many points you get in each problem, add them all up to get your total score. Okay, so maybe you missed 1 point because of that. Are you able to see your grade? And do you see my feedback? Because I do put feedback what you miss there. So look at the feedback and see what you miss and then submit that. Okay. And then, so on our website, we go up. Do you see spreadsheets to calculate my grade? Okay. So here you can play with that. So our exam 1, maximum score is 100, exam 2 100, exam 3 100, exam final exam 100. Okay, so you play with that. Okay, that's the total percentage. And then your scores. So you can put your exam 1 score here, exam 2 score here, exam 3. We don't have exam 3 and final exam yet, but you can put some numbers here to calculate how many points I need to have on my exam 3 and the final exam in order to pass the course. Okay, anybody? Questions?
On that one, does it automatically replace the?
Yeah, right. So if you get like if you get 65 here and you get 40 here, your 65 will replace the 40. So yeah, you use your final exam score to replace one lowest midterm score. Okay, everybody. So you can use this Excel sheet to calculate your grades. So in Blackboard, or maybe some coach tell you an overall grade, and that score is not correct because you know we have 38 homework. Each homework is 10 points, but homework is just 5%, and your exam is like 20%, right? So that's why the overall grade just add up the points value. That's not so accurate. So that's why I put this Excel sheets here. You can use this to calculate your grade. Okay, everybody. And for the homework sets, before, even though it's already past the due date, you still can submit those. Okay, you can redo the homework and improve your scores.
Like when you comment on this, you can just resubmit it the way you said resubmit.
Yeah, resubmit and miss the corrections, right? Problem 5 and 90. So resubmit and do 3 points. Yeah, exactly. Good. Awesome. Okay. And then, yeah, this is the grade descriptions. You see how many score you get, and then you can see. Questions? Okay. Yes. If you have questions, feel free to come and see me. Oh, okay. So today we should talk about 6.1, but we are still in 5.3. So we gotta catch up. Okay, so come back to trick. Okay, come back to trick. So last time we talked about the trig identities. Remember the hexagon? Yeah, that hexagon in your mind. So sine, cosine, tangent, 1, cotangent, secant, cosecant. Remember the hexagon? The diagonal, the product of the two n equals the middle one. So sine times cosecant equals 1. Cosine times secant equals 1. Tangent times cotangent equals 1. Right, everybody? Reciprocal properties. And there are 3 upside down triangles. So sine squared plus cosine squared equals 1. 1 plus tangent squared is secant squared. 1 plus cotangent squared equals cosecant squared. Yes, everybody? Make sure you can memorize the trig identities. And here we have a 6 trig functions and the common angle values. And the common angle we have 0, right? So 0, 30 degree, 45 degree, and 60 degree, 90 degree. You look at the sign first. The rule is square root of n over 2, and you let n goes to 0, 1, 2, 3, 4. Therefore, 0, 1 half, root 2 over 2, root 3 over 2, and 1. Right, everybody? No cosine, same number, reverse order. Tangent, sine over cosine. 0 over 1 is 0. This guy over this is 1 over with 3. This guy over this, because they're the same thing, so 1. This guy over this, we're 3. And 1 over 0, undefined. Do you remember that, everybody? That is tangent. Cotangent value, same number, but reverse order. Okay. And then secant. Secant is 1 over cosine. Therefore, 1 over 1 is 1. Here, reciprocal, 2 over 3. Here, reciprocal, square root of 2. Here, reciprocal, 2. 1 over 0, undefined. Okay, everybody? And then cosecant, same numbers, but reverse order. Okay? So this is how we remember the values of this table. So these you gotta memorize. Okay? Because for this common angle, I want exact value. So I want root 3 over 2. So you write down root 3 over 2. Do not plug this in your calculator and give me a decimal. Is that clear, everybody? So it's very important to remember the values of in this table. Okay, and last time we talked about the reference angle. Reference angle is the angle made with the terminal sides and the horizontal axis. And last time we did some practice, right? And we continue. So using the reference angle, find all 6 trig functions of negative 5 pi over 6. Okay. All right. So we draw, this is the x-axis, this is the y-axis. And then negative. Negative means we go clockwise. Right, everybody? And you know 90 degree is pi over 2. Right? So negative pi over 6. So 5 pi over 6 is smaller than pi. Okay, therefore 5 pi over 6 is right here. So this is negative 5 pi over 6. Bless you. Right, everybody? And what's this angle? Do you see this angle is pi minus 5 pi over 6 is pi over 6. Right, everybody? Yes. By the way, this negative means we go clockwise. But this angle is 5 pi over 6. That's why this small one, they are supplementary angles, right? You add them up, you get pi. Therefore, this angle is pi over 6. Right, everybody? The reference angle is pi over 6. And which quadrant we're in? The third quadrant. Okay, so sine minus 5 pi over 6 and cosine minus 5 pi over 6, tangent minus 5 pi over 6, cotangent minus 5 pi over 6, secant minus 5 pi over 6, and cosecant minus 5 pi over 6. Okay, so the value will be plus or minus of the trig values of the angle pi over 6. Okay. Plus or minus, it depends on which quadrant it's in. Because it's in the third quadrant, the sign is positive or negative? Negative, right? Yes, the sign is negative. Your cosine is negative, but your tangent is positive. Your cotangent, positive. Your secant, negative. Cosecant, negative. Right, everybody? And then the reference angle, pi over 6. So sine of pi over 6 is, what's sine of pi over 6? Look at the picture. Look at your table. Yeah. Sine 1/2. So negative 1/2. Okay. How about cosine? Cosine of that pi over 6 is, yeah. Tangent? √3 over 3. Cotangent? √3. Secant? Yeah, 2 over √3. Cosecant? 2, right? Cosecant, 1 over sine. So reciprocal of that is 2. Is that okay, everybody? So we find the reference angle, and then we also look at the point in which quadrant to figure out whether it's plus or minus. And then you know the sign or the trig functions of those reference angles. So this is how we figure those out. Okay, how about at the angle of 7 pi over 6? Oh, 7 pi over 6, which means we go counterclockwise. But do you see what happened? 7 pi over 6 is the same as pi plus pi over 6. Yes? So, do you see? This 7 pi over 6 is pi plus. This reference angle is also pi over 6. Yes, everybody? Oh, but we want to find the coordinates of the points on the unit circle. So we want to find the coordinates. Remember here, coordinate x comma y. Okay? So it's on the unit circle. X squared plus y squared equals 1. Right, everybody? And x, remember what is cosine theta? Okay, so cosine theta is x over r. But because r is 1 on the unit circle, so cosine theta is x. And the sine theta, which is y over r, because r is 1, so that is the y. And in the third quadrant, In the third quadrant, we know sine is positive or negative? Negative. Cosine? Negative. Oh, so cosine of 7 pi over 6 is negative of cosine pi over 6. But do you see this angle and that angle is actually the same? Yes, everybody? This angle and this angle. They are different by 2 pi. Then you know when you add multiple 2 pi or you subtract multiple 2 pi, you have the same angle. Right, everybody? So therefore, this cosine value is same as this cosine value, which is negative cosine power 6 root 3 over 2. Okay, and the sine of 7 pi over 6 is negative sine of pi over 6, which is 1/2 from the table of those common angle values. So coordinates, see, coordinates. We have the x value. X value is the cosine. Cosine is negative root 3 over 2. That is the x values. And then the y value is the sine. Sine is negative 1/2. Okay, so the point is this point. So far, so good, everybody? Yes. So this is session 5.3. Okay, we learned about the common angle values and the sign of the trick, 6 trig functions on each quadrant. Okay, so let's keep going. 5.4, right? Triangle, trigonometry. So here we have the triangle. So actually these we have did this before. Remember? Sine. So we can use that. Tau. So sine opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposites over adjacent. Cotangent adjacent over opposites. Secant 1 over cosine. So cosine adjacent over hypotenuse, and secant is hypotenuse over adjacent. Right, everybody? Cosecant 1 over sine. Sine is opposite over hypotenuse. So reciprocal, hypotenuse over opposite. Do you remember those, everybody? Okay. Yeah, now we just put them in a triangle. Okay, instead of on the xy plane. Okay, now find the 6 trig functions of an acute angle using a 36, 77, and 85 right triangles. Okay, so here we have, oh, let me see. So let me draw a better picture. Okay, this picture is not so good. Okay, so 36 is so small. So let this be 36. And then 77. 85 is the biggest side. You know the biggest side must be the hypotenuse. Right, everybody? Yeah. Then we let this be theta. Okay, so what is sine theta? Opposite over hypotenuse. What's opposite? 36. Hypotenuse. 85, right? Okay, what's cosine theta? 77 over 85. Adjacent over hypotenuse. Right, everybody? Yes. How about tangent theta? Tangent is 36 over 77. Very good. Okay, how about cotangent? You remember cotangent is 1 over tangent? So the reciprocal of tangent is 77 over 36. Right? How about secant? Secant is 1 over cosine. So we get reciprocal 85 over 77. Right, everybody? Cosecant 1 over sine. Yes, everybody? So we get reciprocal 85 over 36. Right, everybody? Okay. Yeah. Last class, I just told you. See, where's the picture? I thought I have a picture there. It's gone. Do you have your picture? Oh, okay, I see. Okay. I mean that one. Okay, so let me see. 5.2. Okay. I mean that one. I mean this one. Okay. So last time I just told you this is the values. Okay, I told you these values, but then I didn't tell you why we get these values. So now we actually talk about why we get these values. Okay, so let me make it there. Okay, so move it down and shrink it. Yeah. So this table we get in section 5.3. Now we actually show it why we get these numbers. Okay, so remember the special angle, they are 0, 30 degrees, 45 degrees, and 60 degrees, and 90 degrees. Right, everybody? So let's look at 45 degrees. So 45 degrees. Then this angle is also 45 degrees. Do you agree, everybody? Okay, so let the side BC be 1. Then the side AC is also 1 because they have the same angle, so those two sides are the same. They're both 1. And then this number, this side, by the Pythagorean theorem, that's the square root of 1 squared plus 1 squared. Yes, everybody? So that is square root of 2. Therefore, what is sine 45 degree? Let's say this is the angle. Sine 45 degree, opposite over hypotenuse. So that's why we have 1 over root 2. By the way, 1 over root 2 is the same as root 2 over 2. But I prefer 1 over root 2 because I love the simple form. How about cosine? Cosine is adjacent over hypotenuse. Do you see adjacent is also 1? Hypotenuse, square root of 2. Yes, everybody? And tangent. Tangent is opposite over adjacent. So 1 over 1 is 1. Right? Cotangent, 1 over tangent. But tangent is 1. Cotangent is also 1. Secant, 1 over cosine. So do you see the reciprocal of 1 over root 2 is root 2? Yeah? Cosecant, 1 over sine, but the sine is 1 over root 2. So cosecant is also root 2. Is that okay, everybody? So this picture can help us figure out the middle values. See, the angle is 45 degrees, and then we get all the 6 trig functions values. Is that okay, everybody? Okay, let's keep going. How about the 30 degree and 60 degree? They form a triangle like this. Okay, so you see, this is 60 degree, and this is 30 degree. But do you see this angle BAC? This angle is 60 degrees. Yeah? And this angle is also 60 degrees. Right? So let's say all the sides have length 2. Well then, do you see this is a right angle triangle? Okay. Do you see this side BD is 1? And this side CD is also 1? Yeah, everybody? Okay, so this side is 2, this side is 1. This side, by the Pythagorean theorem, we have square roots of 2 squared minus 1 squared. You know, 2 squared is 4. 4 minus 1 is 3. So this side equals 3. 60 degrees. So this angle is 60 degrees. Sine. Opposite over hypotenuse. Opposite is root 3 over 2. Yeah, so root 3 over 2. Okay. And cosine, 60 degrees. Adjacent, 1 over hypotenuse, 2. So 1 over 2. Tangent, opposite over adjacent. Root 3 over 1 is root 3. Cotangent, adjacent, 1 over opposite, root 3. Right, everybody? Secant. Secant is 1 over cosine. See, 1 over cosine. So 1 over 1/2 is 2. Cosecant, 1 over sine. So reciprocal, 2 over root 3. Is that okay, everybody? Mm-hmm. So these 6 numbers help us to figure out this column. Yes, everybody? Mm-hmm. Okay. Therefore, last one is the 30 degree. What color that I haven't used? Blue one. Okay. 30 degree right here. See, 30 degree. Sine. Opposite is 1 over hypotenuse is 2. Okay, this is 30 degree, right? Cosine. Do you see adjacent is root 3? Hypotenuse is 2. So root 3 over 2. And then tangent. Tangent is opposite over adjacent. Cotangent, adjacent over opposite. Secant. Secant is 1 over cosine. And so 1 over that reciprocal is 2 over root 3. Cosecant, 1 over sine. So reciprocal of 1/2 is 2. Yes, everybody? And this can help us to figure out this column. Okay? And then the rest you know, okay? When the point is on the here, okay? X, Y. X is cotangent, Y is sine. Therefore, at this point, this is 1, 0, so cosine of 0 is 1. Sine of 0 equal to 0. So you can look at this picture to figure out this column and this column. That's why we get the values of this table. Okay, everybody? So when you get home, please make sure you can memorize the values of that table. And also, we have the cofunction identities. So from this picture, you see the sine of 30 degrees is opposite over hypotenuse. But it's the same as cosine of 60 degrees. So if the angle, they are complementary, then you have sine A equals cosine 90 degree minus A. Okay? The cosine A equals sine 90 degree minus A. Secant, cosecant, and tangent and cotangent. for the complementary angles. Okay, and then we will continue next. Okay, yes. Have a nice day.